Hello everyone, today we're going to learn how to solve exponential and logarithmic equations. The first thing is a kind of long video and you have a lot of problems that you're going to be doing. So the first thing I want to get under the way is make sure that you understand the previous standard before attempting this, okay? 3.3, that has a lot of stuff in there, and I think you'll just get frustrated and lost and confused if you're trying to do this without really understanding the previous one. So instead of watching this video, go back and work on that, okay? Once you understand that, though, you can join us here. And the first idea I want to tackle is the idea of the same base, okay? You see this equation right here, 5 to the x equals 5 cubed, or 5 to the 3. The only thing x can be is it's got to be 3, right? So it seems pretty obvious there, but it's a really neat little rule. Here's the general rule. It said if b to the x equals b to the y, then x equals y. It's a very nifty, helpful rule in many situations. So let's see how we can use this. Equations won't be as easy as 5 to the x equals 5 to the third. Instead, those powers look a little different, like in this first one here. 2 to the 3x minus 8 equals 16. Well, I know that 16 is a power of 2, so let's just rewrite it like a power of 2. Let's write it as 2 to the 4th. And once you do that, you see we can invoke our rule that if the bases are the same, then the powers must be equal to each other, if that's the only thing in the equation. So we get 3x minus 8 equals 4, and you guys can solve that on your own to find out that x equals 4. Alright. As far as checking your work on these kinds of problems go, here's our check work cloud. Just plug in the number you got and make sure it comes out to what you get on the other side. Okay, cool. Let's do this one on the right. It's a little bit trickier here. You see 27 and 9. One of those is not a power of the other, but they do share a number that they're both the power of, and that would be 3. So instead of writing it like this, I'm going to change it to write it as, instead of 27, I'm going to write 3 to the third, and instead of 9, I'm going to write 3 squared. Okay, and you can do that. That's perfectly fine. We're just rewriting the numbers that are already out there. Then, as you guys know, when you have a power and you raise that to a power, you have to multiply the exponents, right? So we're going to do 3 times x plus 3, and we're going to do 2 times x minus 1. Alright, those are, again, back to our power rules. Now you can see, look, we have our same base situation up here as we did at the top up there. So that means those equations are equal, and after a little bit of distributing and just rearranging the equations, you get x equals negative 11. Okay, and you can check it the same way. I don't do that here, but I would highly recommend that you do it. So go ahead and do these next two down here before coming to class. I'd recommend trying them now while the examples are fresh in your mind. Okay, moving on, we have most situations are where the bases are different and are not as nice. You know, most real-world situations, you're not going to get, oh, look, this is the power of the other. So, for example, this first one here, 4 to the x equals 15. Well, 15 isn't a power of 4 or a power of 2, so we can't do a little changing the bases to make them nice. So, what we have to do is just convert this is an exponential form, let's change this to a logarithm. And this is the whole reason, or one of the main reasons we use logarithms. 4 to the what equals 15? Well, your calculator can find that out for you. However, before you type it in the calculator, that right there is the exact answer. If you write log base 4 of 15, you've already got the answer to that question. Okay. Now, sometimes, and your textbook will ask this sometimes, it'll say, hey, do the exact answer and or round it, or plug into a calculator and round it. I'm not as much a fan of that, but that is good for checking your work. And speaking of checking your work, we have another way to check our work here. That's asking if this makes sense, if it's reasonable. Okay? And the way you want to do that is you want to look at, alright, well, log base 4 of 15, I don't know what that is, but I know what log base 4 of 4 is, and I know what log base 4 of 16 is. Since 15 is between 4 and 16, the answer must be between 1 and 2, and it's probably closer to 2 because 15 is closer to 16. look at what we have. 1.95 is pretty close to 2, so I would say yes, our answer is reasonable. But like I said, the exact answer, and that will often be asked for on quizzes, is that first part. Make sure you write that down. Don't just write the decimal down. Okay. On the right here is just another example of this. Log base 10. We don't need to write the 10 down there, so you can just type in log of 120,000. Sorry. And again, that's the exact answer. Okay. This right here. And you can stop there if that's all I ask for is just the exact answer. But if I ask for decimals, you just type it in a calculator. Now, something about typing in a calculator, I have this right here. I highly encourage you to find a calculator that allows you to type in bases, like the first one we did back there, log base 4 of 15. Ironically, the TI 82, 83, 84 families do not let you type it in like that, and I'm not going to spend time showing you how to, but there is a way to get the answer using those calculators. It involves a little bit of a math trick, but yeah, come ask me if you need help with that. Alright? So go ahead, try these other two before coming to class and before we move on. Alright, now that you got that, it's time to get onto the doozies, the tough equations. Alright? These equations down here, you notice we don't have change of base and we have variables on both sides. So the thing that we have to do is we have to take the log of both sides. Now, one question is asked, before, if we would square both sides, there'd be extraneous solutions. That actually doesn't happen here because because the logarithm function is a one-to-one function. Okay, it's still good to check your work afterwards, but yeah, you're allowed to take the log of both sides. And now we're going to use some of those logarithm rules that we had from the previous unit. Okay, so you see how there's 5 to the power up there, to the x minus 2 power. We're just going to bring that down in front because having a power inside a logarithm is the same as multiplying that number outside the logarithm. And we're going to do the same to the right side there. Once you have that, you just distribute the logs. Okay, just treat them as numbers. A lot of students get freaked out and say, there's letters now, what do we do? Just treat it like a big number. You can type log 5 and log of 4 into the calculator and get decimals, and then you're working with decimals. I think that's just as messy, and you start to round right away. Here we still have an exact answer, so especially if I ask for an exact answer, you need to keep all these logs here and have it to be this hideously long equation. So I'm just going to rearrange my expressions here, ask questions later if you're wondering how I got any of these steps. Then we're going to factor that x out because we have an x on both of the sides on the left. And the very last thing, I ran out of room, but hopefully you have a little space for this. The very last thing is just divide by that large expression, and you get that big ugly monster. Now there is a nicer way to write it. Again, using the log rules, we can condense this and make it a little prettier. Log of 1600 over log of the fraction 5/16. I'll leave it to you to see why those are equal, but you could probably figure that out on your own. Now, so that would be the exact answer. Okay, if I ask for the exact answer, and if I ask you to round it, you can type all of that in a calculator, and you should get about -6.34. All right. Again, if you have any questions on these steps, ask me in class. Okay. Do try this other side. I didn't leave room on this slide, but hopefully you have room on your paper. Try those before coming to class, and I would recommend trying it right now while it's fresh in your mind. Alright, the very last few we're going to do here are actually logarithmic equations where you have a log already on there. These first few are actually fairly easy. It just involves rearranging and turning this into an exponential equation. So you see log base 4 of x plus 3 equals 2. I'm going to do the okay, if you have a question what that is, come ask me in class again. I'll show you because it's really hard to show without me being in front of you. But yeah, we're just converting it into an exponential form, and 4 squared equals x plus 3. Now it's very easy to solve. 13 is x. Again, you can check your work here by plugging it in and just making sure it's equal to 2. That should be a very fast check that I would highly recommend. Alright, let's try this next guy on the right here. The difference is that we have that 3 out in front. Okay, you can't convert something into a logarithmic or exponential equation. You can't convert those back and forth if you have other things outside of the exponents being added or multiplied, okay? It's fine if they're in the exponents, but if that's not all we have, like this 3 times here, then we need to do something else to that to get rid of it so that all we have is a logarithm or an exponent, okay? And the other tricky thing about this, of course, is it's a natural log, which, remember, is just log base e. It's not actually that tricky. So, yeah, to get rid of that 3, we're just going to divide by 3 on both sides, and voila, we have natural log of 2x equals 4. Okay, that reminds me of the joke for the video. You know that lumberjacks make very good musicians because of their natural logarithms. Alright then, moving on. So remember, it's log base e, so we're just going to convert it into an exponential form like we did before, and that right there, e to the 4th over 2, that's the exact answer. Okay, and that's what I would typically want. You can type that in a calculator and find an approximation if you'd like. So go ahead and try these two before coming to class, and again, I would say pause the video and try them right now while it's fresh in your mind. You will learn best by doing that. Very last problem, save the hardest for last, of course. First thing we got to do is use our log rules and combine those x's. There are many ways to solve these kinds of problems, but I'm going to show you guys one of the fastest. Once that's combined, now we can convert this to exponential form. So you have 2 to the 3rd equals this guy. Now you're going to notice I rearranged 2 to the 3rd as 8, so you just move 8 to the other side, and you have x squared minus 7x minus 8. The issue here is that's a quadratic, so you got to remember how to solve quadratics. The way I like to do it, if possible, is to simply factor it, and remember each of those needs to be set equal to 0. So you get x is -1 or x is 8. Okay, and that's actually not too bad. Here I'm going to check my work, okay, and I'm going to check it by plugging in -1. Alright, so log base 2 of -1. This is back into the original equation. I'm really hoping that equals 3. Now, if you can type this in the calculator. If you do that, you're going to notice right away that we have a problem. Uh-oh, log base 2 of -1 probably gives you an error in your calculator. And that's for good reason. If you remember the graph of a logarithm, it doesn't exist on the negative side. That's because if you're asking the question, what does log base 2 of -1 mean? It means 2 to the x equals -1. Well, what kind of number do you raise 2 to make it negative? Like 11? Answer is you actually can't. Okay, so what we just found, we found something called an extraneous solution. So we got to cross that out, and I'll leave you guys to check x equals 8 as well, just to make sure that one works. But yeah, you want to check and make sure that there are no negatives that you're trying to take the log of. Okay, so log base anything of a negative number does not exist. That's another reason to check our work. So when you do this, especially if you see an x squared in there and we find extra solutions, some of those solutions don't actually work, so they're not actually solutions. So, there's probably the best reason to check your work. You actually are going to find out that you have the wrong answer until you check your work. So I would recommend going and try this one on the right again before class, ideally right now while it's fresh in your mind, and I hope that this video was helpful. Thanks for listening, guys.